Hi everyone, today we are going to discuss about chapter number 2 in plus 1 physics, units and measurements. Okay, so in this chapter we are going to learn about different types of physical quantities, then units, dimensions, and again error analysis. Okay, so first of all we are going to learn about physical quantity. So what do you mean by a quantity? A quantity is nothing but anything which can be measured. Okay, anything which can be measured is termed as a physical quantity. Clear? So we have a lot of physical quantities. If you want to name a physical quantity, we can say mass. Mass is a physical quantity. You can measure the mass of a body, right? Suppose we have a object here, so we can measure the mass of this body, right? So anything which can be measured can be termed as a physical quantity. You can measure the volume, you can measure the length, area, etc., etc. So anything which can be measured is termed as a physical quantity. And then the physical quantities can be classified into three types. What are they? First one is fundamental physical quantity. Fundamental physical quantity. And second one, derived physical quantity. And third one, supplementary physical quantity. Clear? Then what is the physical quantity? Anything which can be measured is termed as a physical quantity. Then it can be classified into three types. What are they? Fundamental, derived and supplementary. Okay, again once more I will explain it. So anything which can be measured is termed as a physical quantity. Okay, so let me ask you a question. Can you measure the beauty of something? No, we can measure that, right? We cannot measure the beauty, or we cannot measure emotions. See, can you measure anger? Can you measure kindness? Okay, can you measure happiness? No, there is no index or there is no measurement for such things. Okay, so we cannot count them as physical quantities. Okay, so only anything which can be measured is termed as a physical quantity. So next we will learn about these things: fundamental, derived and supplementary quantities. Okay, so next we are going to learn about fundamental physical quantity, right? So the word fundamental, what does that mean? It means basic, right? So these are the basic quantities, or obviously fundamental quantities, which are not dependent on any other physical quantities. I mean, see, mass is independent of length, right? Okay, all of us know that the mass is a separate thing. Okay, it doesn't depend on length, time, temperature, or whatever the other quantities. It doesn't depend on the other quantities, right? We don't need mass or length to create or to form electric current. So fundamental physical quantities are the quantities which cannot be obtained from. Okay, mark my word, listen carefully, cannot be obtained from any other physical quantities. So these are the quantities which cannot be obtained from. Okay, cannot be obtained from any other physical quantities. Clear? Then so we have 7 fundamental quantities. Okay, like I told you before, these are the quantities which cannot be obtained from any other physical quantities, and they are independent to each other. They doesn't depend on each other. Okay, so they are fundamental quantities, doesn't depend on each other, cannot be formed from any other physical quantities. I think I'm clear to you. Okay, so next we will go to learn what are the fundamental quantities. Okay, the first fundamental quantity is mass. All of you know what mass is. Okay, you have learned mass in your 10th, 9th, okay, classes. So what is mass? Mass is nothing but it is the amount of matter contained in an object. Amount of matter contained in an object, that is called mass. So mass is a fundamental quantity. Next one, length. I think you don't need an explanation for length. Okay, Length. All of you know what a length is. What length is. It's another physical quantity, and it is also a fundamental physical quantity. Next one, time, the most precious thing. Okay, so time. Time is another fundamental physical quantity. Next one, temperature. So what do you mean by temperature? Okay, temperature is nothing but, in simple words, we can say that it is a degree of hotness. It's actually there is a difference. Actually, the difference between heat and temperature. Okay, you have to learn the difference between heat and temperature. Usually, we think heat and temperature are the same terms or same quantities, but they are not. Okay, heat is an energy form, but temperature is somehow different. It is the measurement of heat. Actually, temperature is the measurement of heat, or it is the degree of hotness. Degree of hotness. We will learn these things in the coming chapters, in 12th chapter. Okay, known as thermodynamics. So we will learn that in the coming chapters. Okay. Then fifth one, electric current. All of you know what electric current is. Okay, if you want a definition, we can say that electric current is nothing but it is the rate of flow of charges. It is another fundamental physical quantity. And next one, amount of substance. Okay, when I say a term, you will easily understand what amount of substance is. The amount of substance, you know, Avogadro number, right? 6.022 into 10 raised to 23, and something related to that, the number, the amount of substance contained in a atom or molecule or something like that, and it's called amount of substance. It's another fundamental physical quantity. And last one, luminous intensity, the intensity of light or something related to that. Okay, it's called a luminous intensity. This is not a, this is not an important thing you have to learn here, because you have to memorize only the word. Luminous intensity is a fundamental physical quantity. We don't have any explanation in the next chapters or something like that. Okay, we don't have any explanation. So we don't need an explanation actually. Don't need that. We are learning this quantity only in this chapter. Okay, so just memorize the word, or just remember that word, luminous intensity, and it is a fundamental physical quantity. So once again, I will tell you what is a fundamental physical quantity. The quantity which cannot be obtained from. Okay, the quantities, these are the quantities which cannot be obtained from any other physical quantities, and they are independent to each other. And they do not depend on each other. It's independent to each other. They are basic quantities. Okay, 7 fundamental physical quantities. What are they? Mass is the length, time, temperature, electric current, amount of substance, and luminous intensity. Okay, say with me, mass, length, time, temperature, electric current, amount of substance, and last one, luminous intensity. Okay, in your exam, they will not ask what is mass or what is temperature. Okay, they will ask like, they pick the odd one out, or which one of the following belongs to fundamental physical quantity. The questions will be like that. Okay, so there are 7 fundamental physical quantities. What are they? Mass, length, time, temperature, and again electric current, amount of substance, and luminous intensity. Clear? So next we will go to discuss about what? Derived physical quantity, the second type of physical quantity. So fundamental is finished. Next one, derived. Okay. So students, next we are going to learn about second type of physical quantity, that is derived physical quantity. It's another type of physical quantity, derived physical quantity. Okay, it's very simple. So what do you mean by fundamental physical quantity? The quantities which cannot be obtained from, okay, the quantities which cannot be formed from any other physical quantities are called fundamental physical quantities. But in the case of derived physical quantities, the quantities which are formed from fundamental quantities, or the quantities which are formed by using any other physical quantities, are known as derived quantities. The word itself gives a meaning, right? So that is what do you mean by derived? Something is formed from any other, or depends on any other thing which is formed from any other objects. That's known as derived. Okay, derived. So derived physical quantity means a quantity which is formed from fundamental physical quantity or any quantities which can be formed from or which can be obtained from any other physical quantities. Clear? Then there are a lot of, we have only 7 fundamental quantities, but we have a lot of derived quantities. Okay, for example, area is a derived quantity. Okay, see, area is nothing but length into breadth. Okay, simply for any geometric shape or whatever, the area is length into breadth. Okay, all of us know that length is a physical quantity, fundamental physical quantity, right? And breadth, it's also measured in meter or centimeter or inch or feet, whatever. It's also, it's equivalent to length, right? Breadth is also an equivalent quantity like length, and quantity like length. Okay, it's equivalent to length. So length and breadth, we can classify, or we can call both length and breadth as length. Okay, we are measured in centimeter or millimeter or meter. So we are measuring both length and breadth in the same unit or in the same manner. So we can call it as a fundamental physical quantity. So length into breadth gives you area. So we need length, the fundamental physical quantity, to form area, which is a derived physical quantity. Again, next one, volume, length into breadth into height, right? Next, density. Okay, all of you know density. What is density? Density is nothing but mass by volume. So here, mass is a fundamental physical quantity and volume is another derived quantity. So using two different quantities like mass and volume, we can form density. Okay, this is the difference between derived quantities and fundamental quantities. You cannot form mass by using any other quantity. So mass is mass itself. It doesn't depend on any other quantities, but density is not density itself, but it depends on mass and volume. Mass and volume. So this is the difference between derived quantities and fundamental quantities. I think the concept is clear to you. So what is fundamental quantity? The quantities which cannot be derived from any other quantities. Okay, that is called fundamental quantities. And derived quantities are the quantities which can be formed from or which are derived from another quantities or which are formed using fundamental or any other quantities. Okay, that's all. That's the difference between derived and fundamental quantities. And we have one more type of physical quantity. It's another category, and it is known as supplementary quantities, and we will learn about supplementary quantities next. Next, we are going to learn about two different quantities. Okay, supplementary quantity. So we have learned fundamental physical quantity, then also we have learned derived physical quantity, and there is another category which is neither fundamental nor derived. Okay, we cannot categorize these two like fundamental or derived. So we have classified these two quantities in another way, that is called supplementary quantities. Supplementary quantities. So you can see that there are only two supplementary quantities. Only two supplementary quantities. There, the important thing is they're not belongs to fundamental. They are neither fundamental nor derived. Okay, they are another type of quantities. Supplementary quantities. We have two supplementary quantities. First one is plane angle. First one is plane angle. This is the common angle you have learned in your textbook, in mathematics books. Okay, so this is nothing but it is very simple concept. The common angle, the angle measured formed by two lines. Okay, so I think all of you have learned the concept of arc. Okay, the concept of arc. Suppose this is an arc. This is an arc of length L. This is an arc of length L, and the arc makes an angle theta. Okay, the symbol for plane angle is theta at the center, and r is the radius. Then we have an equation here. The angle is equal to arc length by radius. Angle is equal to arc length by radius. It is very simple concept and very important concept. Okay, we need this concept in several things. I mean several further things like suppose we are going to study about the circular motion, we need this concept. Okay, so this is something related to circle. So an arc is a part of a circle, and this is the center of the circle, and this arc subtend an angle theta at the center. Okay, simple concept, theta at the center. Then the angle, plane angle. This is called plane angle. Angle in a plane. This surface is a plane. So the angle in a plane, that's called a plane angle. Simple. Okay, so theta equal to L by R. What is L? Arc length, and R is the radius. Okay, simple concept, theta equal to L by R. Clear? Then next one is a new concept for you, solid angle. Okay, so what do you mean by solid angle? See, suppose I have a solid object like this room. Okay, like this room, the rooftop is a surface. So suppose a point here, and the rooftop, we can join the lines from the corners of the rooftop to this point like this. So this is the roof, or this is somehow a small area. Okay, small area, and we can join the corners to a point, central point O, and this area makes a angle, a three-dimensional angle. Okay, just imagine this is a three-dimensional concept. So makes a three-dimensional angle at this region or at this point. Okay, it's a three-dimensional concept. I cannot draw it. I cannot draw it in the plane. Okay, so it's a three-dimensional concept. You have to imagine that. So it's an area. It's an area actually. Okay, it's an angle in the form of area. Okay, somehow different. Okay, so just imagine it's an area, and that area, this solid substance makes an angle. The solid substance makes an angle at the center, and that angle is called a solid angle. That angle is called a solid angle. The solid angle is represented as d omega, a small angle. Okay, this d, this small letter d is a symbol. Actually, it represents this omega, the angle, the solid angle is very small. Okay, it's very small. So this is a small solid angle equal to area of the surface dA by the square of this radius r square. Okay, so d omega equal to dA by r square. Very simple concept. I think in your exams they won't ask this. Maybe they will ask in the JEE exam. Okay, JEE exam, and maybe in the NEET exam also. But I don't think they will ask in your public exam. There are CBSE or state, they will not ask this. But just remember that this is the solid angle d omega equal to area dA. The area is this area dA by r square. dA by r square. So these are the two supplementary quantities, plane angle and solid angle. So what is plane angle? It's simply the angle. Okay, the angle angle in a plane. Okay, like this theta. Okay, because see, this is also an angle. This is also an angle theta. Okay, this is the concept of plane angle. Simply the angle we have learned in mathematics. Okay, so this is another concept, solid angle, the angle made by a solid surface at center. Okay, so these are the two supplementary quantities. So far we have learned three types of quantities. So what is a quantity? Anything which can be measured is called a quantity. Okay, anything which can be measured is called a quantity. We have three types of quantities. What are they? First one is fundamental physical quantity. The quantities which cannot be derived from any other quantities are called fundamental physical quantities. And second one, derived physical quantities. So what are derived physical quantities? The quantities which can be formed from any other quantities are known as derived physical quantities. And third one, supplementary quantities. They are not derived, or they cannot be categorized as derived, or they doesn't belong to they doesn't belong to fundamental either. Okay, so such type of quantities are called supplementary. We have two supplementary quantities, plane angle and solid angle. So if you are given the arc length L and the radius R, then the plane angle theta equal to L by R. Okay, that's all. So these are the basic things about fundamental, derived and supplementary quantities. Very simple, very simple. So we have to there will be no problems from this area. Okay, there will be no problems, only theoretical concept. So we have to learn the difference between fundamental, derived and supplementary quantities. What do you mean by fundamental, and what do you mean by derived, and what do you mean by supplementary. We have 7 fundamental. What are they? Mass, length, time, temperature, electric current, amount of substance, and luminous intensity. Okay, you have to learn all the names, all the fundamental quantities, 7 fundamental quantities, and what are the difference between these things. Okay, so that's all about fundamental quantities. And then next we are going to discuss about another important topic called unit. Okay, so we will go to unit next. So next we are going to learn about units. So what do you mean by unit? Suppose you are going to a grocery shop for buying sugar. Okay, and you went to the grocery shop and you are asking the shopkeeper, so can you give me some sugar? What will you ask? Okay, we always like we want 1 kilogram of sugar, right? 1 kilogram of sugar or 2 kilogram of sugar, something like that. Okay, so what is that? Kilogram. That is called unit. Okay, so unit is nothing but it is a basic reference standard used to represent a physical quantity. It is a basic reference standard used to express or represent a physical quantity. So we have to, in the case of in the example of sugar, we have to represent the mass of the sugar, right? So 1 kilogram is the mass of the sugar we want to buy from the shop. Okay, so 1 kilogram, right? That kilogram, the 1 kilogram, 1 kilogram. This kilogram is the unit. And what is this one? It is called magnitude. So to represent a physical quantity, or any physical quantity can be represented as, listen here, NU, N into U. Okay, any physical quantity can be represented as NU. What is N? N is a number. It will be a number like 1, 2, 3, 4 or 0.1, 0.2, 0.3, whatever. Okay, so it's just a number and it is called magnitude. It represents how much, the amount of that quantity. Okay, if it is mass, then we can say that 2 kilogram. So 2 is the number or magnitude of that quantity and kilogram is the unit. Okay, like if you are measuring the length, it will be 2 meter, right, or 2 kilometer, 20 kilometer, 100 kilometer. So what is that 100? 100 is the magnitude, meter is the unit. Okay, so any physical quantity, listen carefully, any physical quantity can be represented as NU. What is N? N is nothing but N is called magnitude. N is just a number, magnitude, whereas U is nothing but it is the unit. So N is the magnitude and U is the unit. N is the magnitude and U is the unit. Okay, so any quantity can be represented as NU. Any quantity can be represented as NU. N is the magnitude and U is the unit. Clear? So magnitude is just a number. Okay, then we have learned 3 types of physical quantities. What are they? Fundamental, derived and supplementary. Fundamental, derived and supplementary. So what do you mean by fundamental units? The units of fundamental quantities. The units of fundamental quantities are called fundamental units. Very simple. Okay, the units of fundamental quantities. What are fundamental quantities? Mass, length, time, temperature, etc. etc. Okay, so the units of mass, length, time, temperature and the following are called fundamental units. Simple. Okay, then what do you mean by derived units? Very simple. The units of derived quantities. Units of derived quantities are called derived units. Okay, so the units of fundamental quantities are called fundamental units. Then units of derived quantities are called derived units. And we have already learned one more type of physical quantity. What is that? Supplementary quantity. Okay, so the units of supplementary quantities. The units of supplementary quantities are called supplementary units. Okay, very simple. So fundamental quantity, fundamental units. derived quantity, derived units, again supplementary quantity, supplementary units. Okay, so what do you mean by unit? It's a basic reference standard used to represent a physical quantity. Okay, a unit is not a quantity actually. It is just a basic reference standard. We are using it to compare the value or the magnitude. Okay, you know kilometer is greater than meter, right? It's larger than meter, and meter is larger than millimeter. So what is the use of that? Actually, we are comparing the quantities. Okay, all of us know 100 kilometer is very much greater than 10 meter. Actually, we are comparing that. So that is the purpose of unit actually, or also it is used to express or represent a physical quantity, and every physical quantity can be represented as, not every quantity, okay, most of the quantities. Okay, I am not saying every quantity. We will learn some quantities which don't have any unit. Okay, so not every quantity, most of the quantities are represented as nu. What is n? N is nothing but n is the value which is called magnitude, and u is the unit. Clear? Okay, then next we are going to discuss about what are the fundamental units, derived units and supplementary units, and the basic unit systems. Okay, we have to learn some basic unit systems. So next we are going to learn about that. Okay, clear?